This is our next video in half-lives, and this is looking at graphs. What can we tell from a graph? This should look very familiar to you. This was the same type of decay curve that you saw in your graph when you did the licorice or the spaghetti or the string or whatever you used in particular. But it's a decay curve. It's an exponential curve. Over here, you'll want to pay attention to the labels. This is percent of the radioactive material that's remaining after the sample. In this case, it's years. So how do I read one of these graphs? If I'm looking at percent, we know that one half-life means that, or the length of time it takes for half of the material to decay. So if I start out with 100% of the material, a next important part here is this 50. So I'm looking for when 50% of the material remains. So I'm going to come over here and mark that place on my graph. Then I follow it down here. That is 1 year in this case. So the half-life is 1 year. Well, we can follow that through. If I look at year 2, another year, that ought to be half of that material. And here we've got 25%, which is half of the 50%. And we can continue over here and look at, after 3 half-lives, I would have half of the 25%, or 12.5% of the material left. So how do we see this and answer some questions on a graph dealing with a particular substance here? So here I have magnesium 28. That's its mass of 28. It's the isotope that we're dealing with. So over here, I've got the mass in grams. We want to look at that unit. And here's time in hours. So our first question says, what is the half-life of this magnesium 28, and how can we tell? So in this case, I don't have 100% and 50%. That was easy to read before. So I have to pay attention to how much I start with, how much the original material I have, and then how much would indicate that how much I would indicate that I've got a half-life. So half of the 500 grams is 250. So that's this mark right here. I want to trace it down and look at where that lands on this graph, time in hours. Well, that's close enough. It looks like it's 1 hour. So the half-life of that magnesium is 1 hour. And I can tell by looking at when half of the material is left from the original, come over here and then trace it back down, straight shot down on the x-axis. It will tell me the time. And it asks how much magnesium 28 will be left after 1 half-life. Well, that's easy. It's going to be half of the 500, or 250 grams, yes. How much would be after 3 half-lives? Well, this is 1 half-life. We've decided is 1 year. So after 3 years, that's 3 half-lives right here. So how much of that would be left? I trace it back over here, and it should be 50. Well, close to 50. Maybe about 75. So we could do half of the 250 is the 125. Half of 125 is 62.5. So that's 62.5 here. What fraction of the material is left after 4 hours have passed? So this is 1/2 of the material. This one's 1/4. And half of that is 1/8. And this would be 1/16 here. 1/16, or 1/2 to the 4 hours. That's our half-life. So that's 1/16 or 1/16 of the material left. That's our fraction of the material. If I wanted to look at the exact amount, then I would go 1/16 of the 500 grams that we started with. It says, oops, I've got these in the wrong spot here. This one says, what fraction of the material has decayed? How much has actually decayed? How much is no longer left? This is left. How much is decayed? Well, it's the rest of this. I've got 1/16 left, so I would have 15/16 that have decayed. Number 5 says, if 12.5% of the material remains, how many grams of that sample have decayed? If I've got 12.5% remaining, that means I've got 100 grams or 100% minus the 12.5% that has decayed. So whatever 100 minus 12.5 is, so 87.5% of the material has decayed. Then it says, how many half-lives have passed away if 125 grams remain? I look at 125 grams. It's right here. 2 half-lives. So there's a lot of information we can tell from the graph, and using what we've done before. Don't be afraid to pull out your chart that looks similar to this, and it will give you that same pattern that you can use and fill in. It makes it pretty easy to work.